Clemens, tell us where you're working and how you got involved in this HMO research. Tell us a little bit about the history and how did you get interested?
Yeah. Currently, I'm working at the Institute of Nutritional Sciences. Before,
In Gießen, Germany.
In Gießen, Germany. Before, I had been working at the Institute of Physiological Chemistry in Bonn. In 1984, I got in contact for the first time with HMOs because my supervisor, he was very much interested in glycoconjugates, glycolipids, glycoproteins, oligosaccharides, and he got his PhD in Richard Kuhn laboratory. And Richard Kuhn, he is the pioneer who for the first time identified by classical chemical means the HMOs.
When was that?
That was in the 1950s.
So he identified a new component in human milk.
Yeah, right. Yeah.
Which was a big one.
Which was a whole variety of different components. And he was interested because there was this observation from pediatricians that around 1900, Moreau, for example, they realized, Moreau at the Pasteur Institute Tichier, they observed that the feces of breastfed infants is different with regard to the microbiota of formula-fed infants. And then they wanted to find out what's the reason for that. And with time, they realized it's not the protein or fat fraction, it's the carbohydrate fraction. So a few biochemists wanted to characterize those carbohydrates which are responsible for this difference in fecal composition. And that's why Richard Kuhn was interested in identifying those components.
So, and then next step in research, major milestone achieved?
Yeah.
What was what?
A big problem until very recently was characterizing those components, because at that time there weren't no mass spectrometry methods available. It was very difficult. You have to use classical chemical methods. And my supervisor, Professor Egge in Bonn, he was the first one. He got his PhD in Richard Kuhn's laboratory. He was the first one who applied in Europe mass spectrometry to identify HMOs. So for maybe 10, 15, 20 years, work concentrated on identifying these components. That's why we know today we have about 150, 200 different components.
Well, let's go from human milk to infant formulas. There have been infant formulas around for almost 2 decades with so-called prebiotics added. Are these human milk oligosaccharides?
No, these are certainly no human milk oligosaccharides. That's always mixed up in almost any publication. We have a lot of publications on GOS, FOS, on galactosylated oligosaccharides.
They call them prebiotics.
They call them prebiotics.
What are they doing? Do they have similar effects like HMOs or not?
I would first say both kind of carbohydrates cannot be compared, because those prebiotic oligosaccharides which are on the market at the moment, they don't have any structural similarity to human milk oligosaccharides, although in the papers you can always see that they are compared to HMOs because of a similar molecular size, but that's from a scientific point of view just wrong.
But now we can produce them.
That's why it is so exciting now. And we have been waiting since 40, 50 years. First, we had these really huge progress in analytical methods. We can analyze any component, even if they are in very low amounts in the biological fluid. But the biggest or greatest advantage is now that some companies can produce at least some of these HMOs. And for the very first time, we do have HMOs produced which are identical to human milk oligosaccharides. That's unbelievable.